in human history. Bigger than the railroads, bigger than the Industrial Revolution. I mean, it is a whole new world that is dawning. There's the building of the models, and then once those models are built, is the actual using those models to solve very important problems. Early diagnosis of cancer, for example. Surgery that is more precise and more accurate than human beings can do. Robots will be much better surgeons than human beings can be, for all sorts of interesting reasons you might not guess. Anyway, the big opportunity in AI training is upon us, and Oracle is a major participant in building data centers to do AI training. But the much larger opportunity, the one that will truly change the world, isn't the creation of the models themselves, the training of the models. What will change the world is when we start using these remarkable electronic brains, and that's what they are. These are remarkable electronic brains to solve humanity's most difficult and enduring problems. Now, there's one thing that's kind of interesting, where Oracle is explicitly involved, which is, as I said earlier, these AI models are trained on publicly available data, all the data on the internet. So if you look at ChatGPT, Anthropic, Grok, Llama, what have you, they're all trained on all of the data on the internet. In other words, publicly available data. But for these models to reach their peak value, you need to train them not just on publicly available data, but you need to make privately owned data available to those models as well. And that's where Oracle plays a particularly important role, because most of the world's high-value data is already in an Oracle database. We just had to change, and it is past tense, we did change that database so that that Oracle database can take the data that's already in the Oracle database and make it available to AI models for reasoning. So the AI model can reason on not just public data, but on private data. AI is an incredible tool. Some people think it's going to replace all human beings and all of our human endeavors. I don't think that's true. It will help us solve problems we couldn't solve on our own, however. It'll make us much better scientists and engineers and teachers and chefs and bricklayers and surgeons and what have you. We've never built a tool anything like this. I pressed the button and the slide didn't move. I pressed the button again. And this is not an AI device. One more time, and then I'm just going to say the word slide. There we go. Okay. Well, I did both, so who knows why? Who knows why it moved? Okay. I remember when this wasn't called AI World. Remember when it was called Cloud World a long time ago? I had a presentation about AI. Even though it was called Cloud World, I was still allowed to do a presentation on AI. And I said, is AI the most important technology in human history? And ... We're going to find out soon. Well, it's pretty clear. The smartest people I know are working, I didn't press the button. Okay, so not pressing the button. You back up the slide, please. Thank you. I'm just gonna put that down. We can get a better one next time. The smartest people I know are investing fortunes. To be specific, they're investing their fortunes in building and training these AI models. That's how important they are. That's how extraordinary they are. And by the way, Elon, Mark, Sam, in alphabetical order, all really smart guys, extraordinary people. People that this AI thing, maybe it's just a bubble, maybe it's just it's not that big a deal, maybe it's just a bubble. Well, the internet really was, the internet was a big deal. Most people, if you look at the fortunes created on the internet, certainly worked out for Google. Searches seem to pay off. And Elon on that list did start a PayPal, and that paid off nicely. But I know that I've asked him, Elon, he said he definitely didn't put a dime into pets.com. And the thing is, when people talk about bubbles, what is a bubble? And people get exuberant. The internet was an incredible new technology. It remains the foundation of computing, and we couldn't have AI without the internet. So it's incredibly important technology, but people started confusing internet companies like a PayPal or even worse, internet search, worse even better, with pets.com. The fact that I can sell pet food at an e-commerce site, that's something means I'm an internet company. Not really. So yes, there'll be people spending money on AI, because almost every tech company these days call themselves an AI company, but they're not. A lot of them are not. But AI, in terms of its value, this is the highest value technology we have ever seen, by far. Next slide, please. AI. It's interesting because it's called artificial intelligence, but as opposed to artificial perception. But it does perceive. It hears, it smells. Think about smelling. The idea that you can pick up chemicals that are just drifting around in the atmosphere and figure out what those chemicals are. Dogs can smell cancer in patients. We should be able to do that with AI. We should be able to, in fact, there's a project I know of called the Dog's Nose that I'm actually a part of. And we're building sensors, sensors that can smell cancer or other illnesses. But the AI perceives. It's got the part of the brain that hears and sees, in addition to reasoning. It can read street signs. It can read a page on a book. They take a look at you and recognize you. You can identify the song that's playing. You can talk to AI and ask it a question or type it out. And AI can reason logically, very quickly, using language the same way we do, and mathematics. And I was over at Tesla looking at the Optimus robots. And I was curious just how the robots were going to learn, and I just thought about it for a minute and said, well, how would a robot learn how to clean your house or scramble eggs or play the guitar? Well, it would just watch an internet video. It's connected to the internet. It can learn to play piano just like we would watching an internet video. Except it would do it a little faster because it can play the internet video at very, very high speed and learn to play that piece by Chopin in about 5 seconds, which I know my kids can't learn to play piano that fast because I listen to them practice every day. And 5 seconds is out of the question. AI robots will be much better surgeons than the best doctors. There's this very famous surgery started by Dr. Mose, who actually would take cancer lesions off patients' faces. And he was so famous for it because he did the least damage. He took the least amount of tissue off your skin. So cosmetically, he had fantastic results. And what he did, he'd take a couple of layers of skin off and then take that skin over to a microscope and look at it and see, is he taking any healthy cells yet? I mean, how deep does the cancer go? So he's back and forth, cut a little bit of tissue, look at it in a microscope, cut a little bit more tissue, look at it. Well, AI robots don't play fair. Their vision, the vision on the robot, it is microscopic. They can see, they don't need a microscope to see individual cells. They don't need a microscope to see where the cancer ends and the healthy tissue begins. And their coordination, it is exactly, they're better surgeons than we are, not because they're smarter than we are, but because they have better hand-eye coordination. Their eyes are way better than ours, and the precision of their hands is way better than ours, so they can cut between a layer of healthy cells and a layer of cancer cells. It's truly stunning to watch. And it'll make us all, and it'll be very reassuring when we can go to a doctor who's using a robot to do the surgery. The surgery will be perfect. I said this earlier, but it is so interesting. It's built just like the brain. Specialized neural networks, one for vision. I mean, literally a convolution neural network simulates the visual cortex. And the visual cortex has 5 layers. It's right on the back of your head. And evolution produced the very first layer of V1 was just so the animal could first perceive edges of something they were looking at. Then it got up to 4 for color, and the very famous V5 for motion, detecting motion and threats in the environment. The VITs, the vision transformers, that then took that bitmap. So the convolution neural network produced a bitmap, an image, a bunch of pixels, if you will, and then the vision transformer then compares that to things that you already know, and you can recognize faces and things that are familiar. And that's a transformer. That's a VIT neural network for a holistic understanding of the image and recording it. Version 3 of ChatGPT was the one that used the huge transformer networks that did comprehensive language and reasoning. The only drawback with that, the transformer networks, because we had facial recognition long before we had the ability to converse and reason using language with the GPT network. The generalized pre-trained transformer network, which is what is doing the language and the reasoning. But that requires enormous amounts of compute, thus the requirement for fortunes to train these models. These networks, the transformer network is much bigger and much more complex than some of the other networks. As you think, reasoning would be more complex than vision. And then there are networks for certain types of mathematics. Anyway, looks a lot like the brain. So the brain has a lot of, it's amazing. 20-watt human brain, 20 watts. You know, anyone who's screwed into 20-watt light bulb, no, that's not a lot of light. But it's enough to run 86 billion neurons and give you vision and balance and reasoning and language and creativity and the ability of deduction and inferencing. You can do all of that with this incredible, what Elon calls a 20-watt meat, computer. Sensation, recognition, after recognition, the ability to reason on that. Again, the visual cortex is right behind the parietal lobe, behind and below it. The prefrontal lobe, as you can see on the left side, is a big language center. The brain is very specialized, so are the AI models. But we're not building a 20-watt meat computer. We're building a 1.2 billion watt AI brain. Did you ever try to do multiplication as fast as an HP calculator? These electronic brains, these AI models, reason, and they reason very quickly. And they can deal with a lot of data. And they can get to answers that we've never gotten to. This is a picture of a data center we're in the process of building. Actually, it's up and running. Part of it is up and running. Eventually, it's going to have 500,000 NVIDIA GPUs in it. By the way, to give you an idea, 1.2 billion watts. What does that really mean? That's enough to power 1 million 4-bedroom homes in the United States. 1 million. That's a pretty good sized city. And I think we've got a video on the construction.
Oracle is building the world's largest AI cluster for OpenAI in Abilene, Texas. The project began as empty land in June 2024 and is delivering GPUs in less than 1 year. The cluster will contain more than 450,000 NVIDIA GB200s when fully provisioned. Power is provided by a combination of grid power and on-site natural gas turbines. Capacity is provided in 8 separate buildings spanning 1,000 acres, all interconnected together to support a single workload. This site deploys the latest technology across AI accelerators, liquid cooling, and networking. More than 3,500 people work on site each day to deliver capacity at an unprecedented rate. Demand for AI continues to exceed supply, and Oracle is committed to delivering the largest and most advanced AI clusters to support our customers all over the world.
Well, that's a long way from writing code in my bedroom in college. What happened? I have no idea. Okay, so we are in the middle, we trained the very first version of Grok for Elon. We're training a number of other of these multimodal AI models. Almost all of these AI models are in the Oracle Cloud, and I'll come back to that. But yeah, we're probably involved, we're certainly involved in training more multimodal AI models than any other company. And it's very exciting. It's very exciting, and it's daunting. I mean, the size of these projects that we're running it's not just building the network of GPUs, the computer rooms, and the networks, and the cooling, and that was hard. By the way, that was hard in the first place. But now we have to build the power transmission plants. There's a natural gas pipeline that goes to the gas turbines, that fires up the gas turbines and then generate electricity. That electricity then has to be moved to the data center, so it's power generation, it's gas pipelines, power generation, power transmission, data centers, and networks. And those data centers are filled with lots and lots and lots of complex software and a lot of very smart, hardworking engineers. These are enormous engineering projects, each and every one of them. And what we're trying to build are these multimodal neural networks trained on all types of data: textual data, images data, audio, video. Every publicly available piece of data plus synthetic data, we train these models on. Some of the models are designed to be real time. Actually, Google has 2 models. One is Gemini, one is DeepMind. The DeepMind is highly specialized around molecular structures, and DeepMind won a Nobel Prize last year, not this year, last year, won a Nobel Prize on protein folding. You understand, it's taking a molecule where you understand the chemical formula of that protein, a chain of amino acids, and what does it look like in 3D when you fold it up and it's no longer a string. It's now folded. That's a problem we've been working on for a very long time, folding proteins. And they solved it with the DeepMind model that Google owns when they bought DeepMind in London. Elon has two AI models that are very, very different. One is Grok, multimodal AI model. The other is Tesla. And it's a real-time model, and real-time models have some different characteristics than let's say, an Anthropic, which generates code, or a ChatGPT, which is solving a legal problem or a medical problem, something like that. If you're driving cars, things happen very fast. So yes, you have to have vision, you have to have cameras all over those cars, but if something happens, you might be required to respond in a microsecond, in a millisecond at least. A microsecond is really fast. A millisecond in the car, 1,000th of a second. A ball, somebody's coming off a curb, and a bike is following the ball. And you have to see it, understand what's going on, and take evasive action so there's no accident and no one's injured. You have to build things differently when you can't afford the network traffic to go back across the network and talk to a computer, an AI model on a network that's far away. You need a very, very low latency response time. That's why all the Tesla cars, all the Tesla robots have to have local compute in the car, local compute in the robot to make an immediate decision, a very low latency decision. That's not required, for example, if you're writing code. I can tell you what code to write, and you can take a moment to think about it and then give an answer. So the real-time models are a bit different than the models that don't require real time, where you have some time to reason and compute your answer. But both types of models are very important, and both types of models are being built. These models do multi-step reasoning. I know what I'm calling reasoning not long ago was called inferencing. People would talk about, we got to train the model, there's one thing where we train the model, and then when we're using the model, when the model's reasoning, we reduce that to just inferencing, a type of reasoning. That's no longer true. In the early days, that's kind of what models did, was inferencing. Not anymore. They reason like we reason. And there's a list, they do deductions, they do inferencing, they do calculations, they have strategy, they have rules. All the techniques, the reasoning techniques that we use, they simulate and use, but they think a lot faster than we do and solve problems a lot faster than we do, or they solve really complicated problems that we can't solve at all. And that's what makes this so exciting, and it makes this so enormously valuable. These models can answer your questions. They can generate computer code. A lot of the code that Oracle is writing, Oracle isn't writing. Our AI models are writing. We just tell the model what we want the program to do, and then the AI comes up with a step-by-step process to actually do it. We don't write the procedure, we declare our intent, but the model writes the step-by-step procedure. That thing that we commonly think of as a computer program. They diagnose medical images far better than we do. They design drugs that we can't. But there's a big gotcha. There's a big gotcha on these models, and that is, the models do not get trained on your private data, because some reason, private data, people want to keep their private data private. And that's not going to change. But people also want these models to reason on their private data. You know, have your cake, eat it too, whatever you want to call it. I want to keep my data private. I don't want to share it with anybody else. However, I'd like to use this enormously powerful tool to reason on my private data. And that's what what's one of the big things Oracle's been applying itself to in terms of solving that particular problem. And we have this new thing where we're talking about this week here in Las Vegas is the Oracle AI Data Platform, the Oracle AI Database, and the Oracle AI Data Platform. And interesting thing about the AI Data Platform, it includes a multimodal model of your choice. Well, a multimodal model of your choice. Okay, that's great. And so if you want to use Grok in the Oracle Cloud, you can use Grok. If you want to use ChatGPT, you can use ChatGPT. If you want to use Llama, you can use Llama. You want to use Gemini, you can use Gemini. And we'll attach that model, the model of your choice, to not only the public data, the model's already connected to the public data. That's done. But we give you the ability to add your private data to the model's library of information and knowledge. So the model can reason across not just public data, but also private data while keeping your private data private, not sharing it with anybody else. That's very, very important. And it's not easy to do it in a highly secure way. It's not easy. If it was easy, a lot of people would have already done it. Okay, so as I said, the Oracle OCI includes all of the popular multimodal models. You can mix and match, and we have the AI database and the AI data platform that lets you add private data to the models. In fact, I'm going to be a little more precise this time. What it really does, and it's called RAG, by the way. You basically take a bunch of data that the model has not been trained on. And by the way, that might be today's stock prices. I mean, the model doesn't know today's news. The model hasn't been trained on today's news. The model hasn't been trained on today's stock prices. Now, the model knows where to look for, it knows how to ask to look at today's stock prices. It knows how to look at the ticker and get the very latest quote on today's stock prices. And you just put that information in a database that the model can access. And you put your private data in an Oracle database. An Oracle database, the new Oracle database is called an AI database, not just because AI is fashionable. The new Oracle database is called an AI database because it has this RAG capability. It has the ability to take any of the data in the Oracle database and make it accessible to the AI model by vectorizing. So, since a lot of your data is in an Oracle database already, you simply have to ask the Oracle database to put that data in a format the model will understand, and that's called a vector format. And the Oracle database will vectorize any data that you want to make available to the model, and then you can reason on it. By the way, but it's not just data. It's not just data in an Oracle database. The Oracle AI database will vectorize. Let's say you have a lot of data in OCI Object Store, or Amazon Object Store for that matter. And you'd like to make that data available to the model, to the Oracle AI data platform. No problem. The Oracle database can go into OCI Object Store and vectorize and create what's called a vector index to data in OCI Object Store. It can go into Amazon cloud storage and vectorize portions of that that belong to you and make that accessible for reasoning by the multimodal model. So you're not restricted to data that's just in the database. The Oracle database can vectorize anything that's in an Oracle database, a different database, a different cloud, and make that data easily accessible onto the AI model for reasoning. And the reasoning is fascinating. The first thing that Oracle did, so the first project Oracle did in terms of taking private data and making it accessible to AI models is we took all of our customer data and we vectorized it. We basically, and used RAG, and used RAG to make it available to the models. So we started with customer data because we think there's nothing more important to us than our customers. Now, some people who are cynical, you would say there's nothing more valuable to us than our customers. But they go hand in hand. So there were certain interesting questions we wanted to ask. We thought were extremely high value questions. And there's a whole industry called customer relationship management. Well, actually, it's not called that anymore. They changed the name to CX, customer engagement management. Whatever the name is, we know what the questions are. So we ran this project inside of Oracle, took our private customer data, put it in an Oracle database, vectorized it, and used RAG to make it accessible to models, to a multimodal model, an AI model. And then we asked the question, what Oracle customers are likely to buy another Oracle product in the next 6 months? Now, why should that be important to us? And specifically, what product, each and every customer that's going to buy something in the next 6 months, do you mind telling me what product they're going to buy? And you should answer that question. They're most likely to buy. And then one thing, and by the way, it's not just questions that this thing does. You can ask questions, you can prompt it to get answers, but you can also ask it to do things via agents. You can create little computer programs, sometimes not so little, and ask the AI to actually do something, to orchestrate some process. And then we said, okay, let's send a mail to all of our prospective buyers with the 3 best customer references, encouraging them to buy. Now, that request required the generation of a computer program called an AI agent that had to figure out, okay, you're going to buy this product, you're a bank in Switzerland. So we think the best references would be the banks in Switzerland that have already bought that product for you. Those would be the best references for you. So all of the references would be customized based on what we know about you as a customer and the exact situation you're in, the business you're in, the products you have, the other banks you have good relationships with, and you can call for a reference. Anyway, it's extremely interesting that it can solve a problem like this so quickly and tell us what the sales force should be concentrating on at Oracle over the next 6 months. Kind of amazing. Okay, so that application, that AI agent, if I can just back this up one, I'm gonna have to, can you back up my slide once? Okay, the last thing, the last line, send an email to prospective buyers with the three best references. From that single line, we can generate the AI agent to actually do that properly. You can generate the AI agent. Or if you wanted to do a little bit more, you could get even more precise. You could add more things to it, what exactly what you want to do. What kind of letter do you want to send them? What else make the agent even more capable. And that's actually what we did. And by the way, that I don't know if you've heard this term. I mean, I thought it was a little strange the first time I heard it. Vibe coding, right? Sounds very Gen. What is the latest one? Z. Sounds very Gen Z, which is, just say what you want the program to do, generate the prototype, and try it out. Don't think about it too hard. Just get a feeling for it. Feel the vibe, I guess. But that's actually, I mean, you can't use English. You can't generate computer programs directly from English. Personally, I've had debates with other engineers here at Oracle about whether using English as a programming language is a good idea, because English is notoriously imprecise, and wouldn't we be better off if we want to generate programs to create a custom, highly precise declarative language for computer programming? Well, that's what we did at Oracle. Using Apex, we added a declarative AI generation language to Apex for generating applications. But there are plenty of people out there, still working with English, and that's fine. It's up to you. We don't make those decisions for you. We just make sure that you have options. But most of the new applications that Oracle is creating now are agents, are AI agents that were generated, not handwritten, that were generated, and they're connected by workflows. And the interesting thing, when we generate these applications, there are no security holes in these applications, because the application generator doesn't forget things and leave things out. It doesn't make those kinds of mistakes. Every application that we generate is stateless and reliable. In other words, if the computer that application was running on suddenly blows up, loses power, whatever happens, someone catches fire, that application can immediately restart in a different data center because it is stateless. And even though it stopped running in location A, it will pick up running in location B without missing a beat, without losing any data, without the customer ever perceiving it. So when you're generating these applications, they have built-in backup, built-in no single point of failure, built-in reliability, built-in security, and built-in scalability. All the applications are written so. This isn't a lot of people. These low-code application programming languages are designed to write departmental things. Maybe they work for 20, 30, 40 users, but after that they start to slow down because they're really not designed to scale to millions of users. Well, because we generated. The design is always the same. We always design it for millions of users, even if there are only 5. It will run faster that way, use fewer resources. The productivity gains we're getting from this is one of the reasons we feel so good about our efforts in healthcare, that we can rebuild the Cerner code, the Cerner code base. We can rebuild the entire Cerner code base, modernize it using AI, build a modern version of Cerner by generating it. And we got all of the code for clinics operating already. And next year we'll have all acute hospitals. We'll rewritten everything that Cerner wrote over a quarter of a century. We'll have rewritten in 3 years, but what ours does is much more than theirs ever did. We attack the problem not just as automating a hospital or a clinic, but automating the entire ecosystem. Those are the kind of enormous productivity gains you get when you use these incredible AI tools. The example of rebuilding Cerner is fascinating because it's really not what we're doing. We're not just, yes, we're rebuilding Cerner, but we're also building accounting systems for hospitals, designed for hospitals, HR systems designed for hospitals, and hospitals are very unusual. They're kind of 50-50 gig economy in and out. A lot of nurses, they'll work for one hospital, they'll work for private patients, they'll have schedules, you don't know how many nurses you need, or doctors for that matter, you need on Monday. It depends what you're doing, how many patients you're seeing, how many operating theaters are available. So an HR system for a hospital is very, very different, complicated. There's a lot of certifications that doctors and nurses and other health professionals, technicians have to get in order to do certain tests, in order to do certain procedures, in order to handle certain patients. And our HR system has to deal with there's the certifications, schedule the training, schedule when they're working. They have they trade shifts a lot. Be flexible about doing all of that, paying them properly when they're working a lot of overtime, but also understanding when they're only working 2 days a week here and 4 days a week, 4 days that week at another hospital across town. So we're building HR systems and accounting systems and banking systems, and this will be the one that maybe surprises you. And then I'll go into my example. And banking systems that cater to hospitals, making hospitals loans based on their receivables. And so here's, I'm going to describe an AI agent. So our goal was to not just automate hospitals like Cerner did or other competitors of ours do, automate hospitals and automate clinics. We thought, following Elon Musk's rule, that if we really want to be successful in healthcare, we can't just automate hospitals and clinics. We have to automate the entire ecosystem. Like Elon had to build a worldwide charging network, or electric cars weren't going to work. He couldn't just make the cars and assume that Standard Oil would provide the fuel, which is what Ford did. To build electric cars, he had to not only design an electric car and manufacture batteries and put robots in the manufacturing plants and figure out how to sell cars on the internet. He had to build a worldwide network of charging stations. He had to solve he had to build a complete ecosystem for electric cars. If we want to automate hospitals and clinics, those hospitals and clinics are not going to be very efficient if the people who regulate those hospitals and clinics are not also automated. If the patients who are making appointments or receiving the results of a blood test and all of it, if the patients are not also have access to that automation technology, you have to automate the patient, the provider, the payer, the regulator, the pharma companies, banks who finance the hospitals, and governments who regulate the hospitals and collect information from the hospitals. You have to automate the entire ecosystem. Then you will get a truly modern, efficient healthcare system, and that's what we were after when we bought Cerner as a first step. Anyway, one of the most interesting AI agents we've ever built connects providers to payers. Because this is a very interesting problem, and it took me a while to fully grasp this problem when we were working on this. And that the best possible care, what do we want the hospital to do? The hospital has to figure out what is the best possible care I can give this patient. Well, that's kind of true. But let's say you're in the UK and the best possible care said that you have high blood sugar and I've got to put you on Ozempic or another GLP-1. Well, guess what? The NHS in the UK doesn't pay for Ozempic. They won't reimburse you for it, and it's very expensive. So are there any other drugs that will help you manage your blood sugar levels? So yes, there are. And are they pretty good? Yes, those drugs are pretty good. And will the NHS reimburse you for those? Yes, they will. So what you're really doing when you're automating a hospital in the UK, what you're doing is you're trying to work with the doctor to come up with the best possible quality of care that is fully reimbursable if the patient can afford to pay themselves. So those two things are tightly coupled together. So to build this agent, so it's pointless to prescribe Ozempic to someone in the UK who can't afford it. And because their insurance, the government is the insurance company in the UK and NHS doesn't pay for Ozempic. It's true today. So this is what we had to build. And we had to build something that worked in the United States and in the UK and all over the world and solve this problem. The problem was to the best possible care that's fully reimbursable. That's what our goal was. So the AI model that we built first used RAG to access the latest medical literature and the latest test results in the EHR, vital signs, and all of that information, all your blood tests, to assist the doctor to come up with the optimal, the best possible care. And we had to know things like, well, there's a new clinical trial for this particular type of cancer that applies to this patient, that the doctor should consider putting this patient in that clinical trial. So the AI model, not surprisingly, it will have all of the latest information about clinical trials, which drugs are, which drug is working better than the other drugs for this particular patient the doctor is looking at. So we'll provide information to doctors. The AI model will provide information to doctors as the doctor tries to figure out the best possible care for the patient. Then the AI model is also trained, uses RAG to access the latest rules and policies. Now in the United States, those would be insurance policies and rules, depending what insurance do you have? Do you have Medicare? Do you have Medicaid? Do you have supplementary insurance? What are all the different things you have? So I got to figure out what is covered, what do you get reimbursed? And it's really those intersecting sets. What's the best care? What's fully reimbursable? So I have to train the model on all of the insurance rules. And so to make sure that what the doctor is prescribing is fully reimbursable. And I've got to catch little snags along the way. Well, actually, I do reimburse for Ozempic in the UK if your body mass index is beyond this point. And I've got to make sure that the doctor knows that, and I can let the doctor know. Actually, this is an exception. This patient is eligible for Ozempic because they're overweight to pass a certain threshold, and the rule that was just changed says that they now can get Ozempic. I had to do that. So the AI agent then reasons with all of this data to propose the best care, the best possible care, at the highest reimbursement level achievable. That's the goal of it. We're in most places in the world where the government is the payer of healthcare. And the one last thing which that we also did, and we have examples of this that we've experienced, where a lot of clinics, a lot of hospitals in the world, including in the United States, don't have lots of cash on hand. And if they haven't gotten the reimbursements on time, sometimes they can't provide care to new patients. They're just running short of cash all the time. And what the AI agent can do here is give the bank all of the information about a particular collection of reimbursements assuring the bank that those reimbursements will adhere to all of the reimbursement rules, and the clinic and the hospital will in fact be reimbursed. 99% chance, 95% chance they'll be reimbursed. You can discount a little bit, and the bank will then loan on those, on those receivables. So it's a fascinating set of problems. When you look at the healthcare ecosystem, the financial aspects of the healthcare ecosystem, it's very expensive to run. There's a lot of administrative duties, administrative tasks that we can automate away using AI, and let patients spend more time with their doctors who are worried about care, and we can figure out how to get the highest achievable reimbursement, how to get the hospital the cash that they need to continue operating. But that's all done via automation, and the doctor's time and the nurse's time is spent much more efficiently with patients. As I say, AI will make things so much better for all of us. Okay, so Oracle Cloud is very unusual. Oracle's Oracle, in the simplest sense, Oracle does infrastructure and applications. We do scaled enterprise applications, and we do scaled AI infrastructure, and we're the only cloud that does that. The other big clouds, Microsoft, Amazon, and Google really do not do healthcare applications, enterprise applications, big financial applications. They don't do that. In other words, they develop AI technology. They may or may not develop AI technology. Google does. The other two don't. They may or may not develop AI technology, but they're not building large-scaled applications where they're trying to automate industries or automate ecosystems using this technology. So our goals are different than those other clouds. We're a participant in creating AI technology, and we're also a participant in using that technology to solve problems in different ecosystems, in different industries. And we're obviously very large in training AI models, and we have those models, a bunch of those models. Some of which we trained, some of which we didn't. We have those models in our cloud for you to use to solve your problems. For you to do AI reasoning on your private data to solve the problems you want to solve at your company. We have AI code generators. Anthropic is the thing they're most famous for. Anthropic is code generation. We've been doing this for a long time. We think we have that our new Apex code generator is the. Well, one thing I can say about Apex. Every application it generates is scalable, secure, reliable. Everyone. And we've been doing that for a long time. Now we're doing complete code generation using AI and Apex. We are the only ones that are building suites of applications to modernize not just industries, but complete ecosystems. And healthcare is one example, but utilities is another. And we're taking on entire ecosystems, which makes things work much more efficiently. I mean, you're only as strong as the weakest link in the chain. If you have to interact with a regulator, let's say a regulator that does clinical trials, and the clinical trial regulator says, okay, once you finish your clinical trial, print out all the results and send it to us in boxes of paper. And I won't mention any names, but that happens all over the world. It makes new drugs incredibly expensive and take forever to come out. It's a huge problem. So you have to automate these entire ecosystems as a goal. And then agents, you have to build these complex processes, these robotic pieces of software called AI agents that not only automate processes within a company, but also automate processes between companies. How one company talks to another company, how a hospital talks to a bank. Okay. All right, that's phase one of my presentation. We'll be serving dinner. That's why I arrived a little late, because this way we can go straight to dinner when we're done. Okay, so this is looking at, I went into kind of how the AI